Hello ladies and gentlemen. Today we're going to take a look at the math behind breaking even. So whenever you are comparing two scenarios and you want to determine when their outputs will be the same, you are working with a system of equations. And therefore we need to revisit the methods we use to solve systems of equations. So our example is how many hours would an individual need to work in the sales position and the waitstaff position to earn the same pay. Now this is referring to the video I did just prior to this that was talking about how to calculate wages for different jobs. Now I have the two equations that I wrote up for each of those positions. So this was for the sales position, this is for the waitstaff position. And we are going to look at this as a system of equations. I just completely messed up that curly brace. Let me try that one more time. There we go. And there are multiple ways that we can work through this. We could use substitution, basically the equal values version of substitution, where we set each of these equations equal to each other because they already equal W. We could use elimination method because we have the W's here that could actually cancel out. Tell you what, I will show you both methods. All right, so let's start out with the substitution method. And you get to choose which method you use to solve this, whichever one you like best of the one that I go through here. All right, so for substitution, you want to get one of the equations set equal to one of the variables. All right, so I'm going to use this top equation, and W equals 10H plus 135. That means that in the second equation, I can go ahead and replace W with what it equals from up here. All right, whether W equals a number or W equals an expression, you can always replace W with what it's equal to. If W equaled a purple polka dotted elephant, I could write purple polka dotted elephant right here in place of W. It doesn't really matter. All right, so I'm going to start my new equation with 10H plus 135. All right, so that took the place of the W right there, and then I'm going to write my equal sign. And then the $6.60 times H plus 250. All right, now I'm down to an equation with just one variable. Granted, it's a variable on both sides, but it's still just a single variable equation. Now I'm going to draw a line down the equal sign just so you can see where that balance point in the equation is. Whenever I have a variable on both sides of my equal sign, I like to look for whichever one has the smallest coefficient. In that case, that would be the 6.60h. That's what I'm going to undo. And to undo this, 6.60h plus the 250, these two values are being added together. This is a positive value. To undo positive addition, I need to basically subtract. All right, so if I subtract 660h from this side, I end up getting 0. What I do to one side, I must do to the other. All right, so I'm subtracting 660h from each of these. Now on this side, I'm going to have 3.4h. You could put 3.40 if you wanted. Plus 135 equals, this cancels out to 0. 0h, 0 times anything just zeroes out. And 0 plus 250 is just 250. So that's why this term has been eliminated from the problem. Now I'm down to just two items keeping that h from being isolated. So I have 3.4 times the h and I have plus 135. In order to solve this, I need to use a reverse order of operations. So I need to undo the addition or subtraction first before I deal with any multiplication or division. So I'm going to subtract 135 from both sides. And I'm subtracting the 135 because that's the addition that's on the same side as my variable. I'm trying to remove everything from that side with the variable. This cancels to 0, leaving me with just 3.4 times h equal to 250 minus 135. It's 115. Now in order to undo this 3.4, 115 divided by 3.4. Now this is about 33.82 hours. realistically, with the way that people count time, we would need to work about 34 hours. All right, so this is our actual answer, but this is how I'm going to interpret it. Now, did I ever ask for how much money we would make, like what the same pay would actually be? No. So I don't actually have to go through and calculate the other variable because that's not what I was asked for. All right, this answers the question specifically. Now, if I want to go a step further, let's take a look at the elimination version of solving this. All right, so this was with substitution. Let's look at elimination method. All right, if I subtract, actually, you know what? I'm going to multiply by a negative just so I don't forget to carry my subtraction all the way through. So I'm going to multiply this bottom equation by a negative. So my top equation doesn't change. Bottom equation is now negative W equals negative 6.60H minus 250. And then I'm going to add all of these terms. The W's actually cancel out to 0. 10H plus negative 6.60H is 3.4H. 135 plus negative 250 is negative 115. You notice that these two equations look very similar to each other. If I add the 115 back to the other side, now I'm down to pretty much the same equation, just switched around. I would still have to divide by 3.4. And H would be approximately 33.82 hours. Cannot seem to write properly today. 82 hours, just like it did previously. So whichever method you prefer is the one that you should actually work with. Right? Anything that could be substitution where you basically have both equations with a variable already isolated, where you're setting them equal to each other, you could also use elimination to solve those just as easily. It's entirely your choice how you do this. All right, I'll see you in class.